Hi everyone. In the today's session, I'm going to discuss about OpenGL quadratic surfaces. Topics to be discussed in this session are introduction, what is OpenGL quadratic surface, generate GLU quadratic surface functions, LUT quadratic surface functions, benefits of OpenGL quadratic surfaces, and the conclusion. Introduction. Welcome to this presentation on OpenGL quadratic surface, a fascinating and powerful tool used in modern graphics programming. At its core, OpenGL quadratic surface allows for the creation of complex three-dimensional shapes through mathematical equations, making it an essential component of many cutting-edge applications. From video games to scientific simulations, OpenGL quadratic surface enables developers to create immersive experiences that push the boundaries of what possible. In this presentation, we will explore the basics of OpenGL quadratic surface, how it works, its benefits, and its challenges. By the end, you will have a solid understanding of important technology and its impact on the world of computer graphics. Now, what is OpenGL quadratic surface? OpenGL means Open Graphics Library is a graphics API application programming interface that allows developers to create and render 2D and 3D graphics in application. It provides a set of functions and commands that enable the creation of complex graphic scenes. In OpenGL, quadratic surfaces refers to mathematical representation of surface defined by quadratic equations. These surfaces include various geometric shapes such as spheres, cylinders, cones, and paraboloids. Quadratic surfaces are commonly used in computer graphics to model and render objects with smooth curved surfaces. OpenGL provides several functions and techniques for generating and rendering quadratic surfaces, including parametric equations and procedural generation. Parametric equations define the surface in terms of parameters, allowing for more flexible control over the shape. Procedural generation techniques generate the surface geometry algorithmically, often using noise functions or mathematical formulas. Overall, OpenGL provides the necessary tools and functionality to create and render quadratic surfaces, allowing developers to create visually appealing 3D graphics with smooth and curved shapes. Now let's see how to generate GLU quadratic surface functions. To generate a quadratic surfaces using GLU functions, first we need to assign a name to the quadratic, then activate the GLU quadratic renderer and designate values for the surface parameters. The following statements illustrate the basic sequence of calls for displaying a wireframe where sphere centered on the world coordinate origin. GLU quadratic object into sphere 1, where sphere 1 is equal to GLU new quadratic. GLU quadratic draw style of sphere 1 GLU line. GLU sphere of sphere 1 are in longitudes and in latitudes. Where sphere 1 is the name of the object, the quadratic renderer is activated with the GLU new quadratic functions, and then the display mode GLU line is selected from sphere 1 with the GLU quadratic draw style command. Parameter R is assigned double precision value of the sphere radius. N longitudes and n latitudes are numbers of the quadrats. Then comes with the next topic, that is GLU quadratic surface functions. The first one is sphere. Let's see the function. Glut wire sphere of r comma n longitudes comma n latitudes r, that can be represented in another way also. Glut solid sphere r comma n longitudes and n latitudes, where r is the sphere radius which is double precision point. N longitudes and n latitudes is number of longitude and latitude lines used to appropriate the sphere. Next, second one is the cone, and the function is glut wire cone of r base height, comma n longitudes and n latitudes. Or it can be represented in another way: glut solid cone r base height n longitudes and n latitudes, where r base is the radius of the cone base, where which is double precision point. Height is the height of the cone, which is double precision point. In latitudes and in latitudes are assigned integer values that specify the number of orthogonal surfaces lines for the quadrilateral mesh approximation. The third one is torus function. Let wide torus of R cross section, R axial, R concentric, and R, N radial slices, or let solid torus of R cross section, R axial, and R concentric, and N radial slices, where R cross section radius about the coplanar z axis. R axial is the distance of the circle center from the z axis. N concentric specifies the number of concentric circles with center on the z-axis to be used in the torus surface. N radial slices specifies the number of radial slices through the torus surface. Next, let's see the benefits of OpenGL quadratic surfaces. OpenGL quadratic surface offers a multitude of benefits in various applications. One of the key advantages is its ability to render complex 3D graphics with ease, making it an ideal choice for gaming and virtual reality application. Additionally, OpenGL quadratic surface can be used for scientific simulation, such as modeling weather patterns or simulating chemical reactions. Due to its high precision and accuracy, another benefit of OpenGL quadratic surface is its flexibility and compatibility with different hardware and software platforms. This allows developers to create applications that run smoothly on a wide range of devices from desktop computers to mobile phones and even specialized hardware like VR headsets. Now let's come to the conclusion. In conclusion, OpenGL quadratic surface is a powerful tool used in the computer graphics to create a high quality and realistic 3D models and animation. It allows developers to implement complex mathematical functions that define the shape of the objects, resulting in the smoother curves and more accurate details. By using OpenGL quadratic surface, developers can achieve greater levels of realism and immersion in their projects. It is important for anyone interested in computer graphics to understand the concept of OpenGL quadratic surface and how it can be used to improve the quality of this work. We encourage you to explore this topic further and learn more about the different types of quadratic surfaces and their properties. There are many resources available online, including tutorials, forums, and open source libraries that can help you get started. Okay, thank you. Have a nice day.